So, I'm happy to talk today about C++26. I don't say any word about me. You might maybe know me already. This is my plan for today. I will talk about the core language, about the library, and about concurrency. And to be honest, there are three, I would say, extremely interesting features inside 26. Reflection, contracts, and finally, stood execution. I will show you examples, if possible. Let's start with the core language. We have reflection. I should say, it's highly probable that we will have reflection in 26. And what is reflection? It's the ability of the program to examine, introspect, and modify its structure and behavior. A very, very powerful feature. How does it work? You see here in front of int two carets. And this transforms the code into the reflection value R. And to bring it back to code, you have to use the so-called splicer. So this is a forward and backwards journey. You can do it in one step. This here is equivalent to that here. Of course, this makes no sense. Only about the syntax. So we have an operator for making out of code a reflection value, and an operator for making out of reflection value code. In my source code examples, I only use one caret, but they changed the syntax in the last days. Okay. I refer to the proposal. You can see it here, 2.9.96. And what I want to emphasize, in particular about the big three, reflection, contracts, and execution, they are a minimal viable product. Meaning, in 26 we will have so much stuff that it makes sense, but more will come in the longer run. This was a small error. What we also have in the reflection proposal are so declared meta functions. These are functions which are declared as const eval. And they can only run at compile time. So in opposite to const export. And what they give back is the reflection type. And this is a universal type which is called std meta info. And now I show you two examples. One example is I often have to answer in my classes. How can I display an enum? This was the wrong button, sorry. How can you display an enum or the enumerators in a readable way? And this is what we can do with C++26 probably. This example is called David because of David van der Voorde, who is the designer or one of the designers behind reflection. And here I have it in a compile explorer example. So let's look at the main function. This is a meta function, meta identifier of. Here I look inside the enumeration, iterate through it, and it display its name and its value. On the right, you can see the name of the enumerator and its value. And maybe you are interested in the missing stuff. This is my enumeration. Get enum data, it's a const eval function. Here I have an array which takes all the enumeration values. I should not say enumeration values. I should say reflection values. You see current E. And then I store here in the std array its name and its value. And these are all meta functions because I run and compile them. And therefore, you can display, for example, the values of an enumeration or ADA. But you can do more. By the way, way more. When you read the proposal, you will be astonished. Get size. Here I play with the class layout. Oh yeah, let me go to the head. Here I have a std array, which has, you see it? The reflection values. And now I determine in this immediately invoked lambda for each value its size. And here in the loop I display them. And so I know on my platform or on this Compiler Explorer platform, int has 4 bytes, float has 4 bytes, double has 8 bytes. Okay, this was reflection. One of the big three. The next one is contracts. They should originally be part of C++20. But now it may become 26. Contracts. This goes back to Eiffel, as far as I know. Jonathan Meyer or something like that. It's called a side-by contract. And a contract specifies interface for software components in a precise and checkable way. Currently, we will support them only for functions. But more is thinkable. A contract consists of 3 parts: precondition, postcondition, and assertion. This is must hold a precondition, must hold up and entry in a function, a postcondition up and the exit, and an assertion, sometimes also called invariant, must hold at the place you apply it. Let me show you a simple example. You have a function f, which takes an I, and here I require precondition I must be bigger than 0, bigger equals 0. And with this syntax, I can specify the return value. And here it must be bigger than 0. And this is my assertion or my invariant. And this is what must hold. And now let me see what we can do. You can apply an arbitrary number of pre and post conditions to a function. You can do it in any order. You have to apply it before the function definition. Yeah, in pre and posts are so-called contextual keywords. This means in this context, it's a keyword. In another context, it's just an identifier. On the contrary, contract assert is a keyword. What you use inside the function definition, you see? Pre-post on the function declaration, contract assert on the function definition. And here's the example. Currently, it throws a runtime error. You can see it on the right. Contract violation. Because I invoked f with -1. And this is, of course, too small. And here you see the message I got at runtime. These are, as I mentioned it, the two big features, two of the three big features of C++26. What now follows is not so big, but convenient. This is honestly one of my placeholders, because I use it heavily in Python. When you return a tuple from a function and you want to say, I don't care, you can just apply the underscore. But in C++, you can only apply it once. And you will get a warning because you never used it. But this changed with 26. In 26, have a look. I have a function. Returning the three values. An int, a string, and a double. But I only care about the string. Therefore, I use structured binding and set the first and the third value. I don't care. This gives also not an error message, a warning. Unused variable. And I find this makes my code very readable. So this is what we can do with 26. Small but nice feature. This is a small but not so nice feature. Looks a little bit scary. What you can do is the following. When you have a parameter pack, you can index the elements. I wrote an article in Germany 2-3 weeks ago. There was a lot of controversy about the syntax. What I want to do is here, I want to add the first and the last. Here we have C++ strings. Here I have numbers. And here's the function. It takes a parameter pack. By the way, this is what I could ignore. The return value, the compiler can deduce it. And then it takes the first element, returns the first element and the last element. And what is new is this index syntax. Now you can address the elements of a parameter pack. the first one and the last one. And what I got is, as a result, hello world, and sum 11. This is also an extremely small but meaningful feature. When you apply delete, you can now specify a reason for your delete. You apply delete when you want to say, this function should not be invocable. And I would say this makes code way more readable. Have a look here. On the right, we see the error message. I have a function which only accepts double in line 6, and a function which accepts any argument, but I deleted it. And here I provided a reason. And now you see it in the error message. Now you see the reason why I deleted it. This may help you. For example, when you implement money, you should delete the copy constructor and copy assignment operator. And therefore, it would be nice to give a reason. If not, you go into jail. And I assume this will become best practice, because readability is what counts. So what is important. Now I come to the library, but honestly, I cannot show you anything here because there's nothing implemented so far. But at the end, I come to stud execution, and I can show you very interesting examples. First of all, we get an in-place vector. This is a dynamically resizable vector with compile time fixed capacity. It's a drop-in replacement for stud vector. Drop-in means it supports the same interface. When should you use it? When memory allocation is not possible or too expensive. Or you have to allocate it in the static memory segment. When stud array is not an option. When you create a stud array, all the data types need the default constructor. But maybe you want to have a different value. So this is a stud in place vector. As I mentioned to you, I cannot show it to you. By the way, this is the proposal. When you want to read the details, follow this link. What we also get with C++ 26 is a free function linear algebra library based on class. I use this heavily in Fortran in my past. So we got basic linear algebra support, and now you can do it in C++ directly. Vector addition, scalar multiplication, you name it. And this interface, this plus interface, is the de facto standard for linear algebra libraries. Now I have to say a few more words. in C++ 23, we got an empty span. Empty span is a multi-dimensional span, or a multi-dimensional view, or a contiguous memory block, such as a vector or array. And this is 23. With 26, we can create subspans. So you see, I have here a span A, and then I create a subspan consisting of the single element 1. Here I create a subspan consisting of the -1 up to 4. This is a one-dimensional thing. We already see it has 3 elements. You can also create a stride. This means you go from the first until the 7th element and take each second one. You take the elements stepwise. Or you can do it, you can essentially make a copy of it. Of course, a cheap copy. And this is a subspan, an extension to the multi-dimensional span. God damn, that's an error. You have to say to me, not span, span. Damn. Now I'm thinking about Monty Python. Let's go on. You will also get debugging support. You can set a breakpoint. Then you can do std breakpoint if debugging. This calls std breakpoint if is debugger present. Returns true. So basic debugging support. But as I mentioned it so far, not implemented. And now to my favorites. Std execution. This is a C++ standard, a standard C++ framework for managing asynchronous execution on generic execution resources. This was previously known as executors or standard sender receivers. When you want to try it out, there's an implementation available, std-exec, which I will use in my example. But this is based on the 8th revision of the paper. So there's a little bit name irritation between the 10th version and the 8th version. But anyway, you can see now in a few seconds what we can do. The 3 main abstractions are schedulers, senders, receivers, and a set of customizable asynchronous algorithms. Let me show you a first example, which is from GitHub. And I adapted it to the current syntax. Here we are. The examples to std executions become really pretty fast, pretty complex, but this is pretty easy. First, I need a execution context, which is in this case my thread pool. This is where I want to perform something. The execution context can also be the main thread, a GPU, or you know it. Then I get a scheduler out of it. Now I prepare to do something. Here, for convenience reason, I create a lambda, which takes I and returns I times I. And now comes the fun part. Now I start on the scheduler with the value 0. And afterwards, function composition is a continuation, the function fun. The lambda function fun is applied. I do it for 1 and I do it for 2. And I say my work package is done when all are done. And here I wait for the completion of the work. I will give you a few seconds to look at this stuff, then I will add a few additional words. This here, what we have here. Line 13 up to line 16 is all done asynchronously. And this is my synchronization point here. Here I wait for all jobs to be done. And this can not only return in value, but also a stopped or an exception. But here I want to have value. So the sync wait has 3 channels essentially. Let me go back and let me explain it once more. We have here 3 components. We have a scheduler. We have senders. They describe work. And you can say we have a producer or the consumer. A consumer. And they run asynchronously. This guy runs synchronously. And that's here, this here. This starts on is a so-called sender factory. This creates the first sender. And all what's come afterwards are sender adapters. They adapt the workflow. And this is the programming side. By the way, I used here 3 instances of compile exploits would not be necessary. I have a second example. This is also from the paper. And this is called Hello World. But let me show it to you live. Once more, I converted it in this std exec syntax, which is pretty similar. I create 8 threads, a thread pool with 8 threads, get my scheduler, and now this call here, std_x schedule. This is my sender factory. Here the sender starts. But the continuation of the sender uses this begin and applies the lambda. In the next continuation, uses this high and applies the other lambda. And here, as before, I wait for the result. And the only place I wait is the line 19. Let me add a few remarks, this is what I already explained. We need execution resources. Send the receivers, this is also not so interesting. But this is interesting. These are the center factories, you see? Schedule just. Say start and sender workflow. These are the sender adapters. You know where already went on, and then there are more which allow you to adapt the workflow. And this is the sender consumer, which waits on the side. And now what you can do is essentially you can with on say on which hardware this should run, and so on and so on. This is extremely powerful. These were the only simple examples I found, but I will analyze in a few weeks more complicated examples. Let me conclude my short talk. We will have in C++ 26. In C++ 26. With high probability reflection contracts and stood execution. 3 features which will change the way we program in C++. And they are so powerful that you can expect more in 29. When you want to learn more about it, read my blog. I currently write about stood execution. And then I will jump back once more to reflection. Because honestly, it takes me quite a time to understand what's possible here. And I'm still in the phase of discovering this. Okay, this was my short talk about 26. And the stuff we will get is high probability. Questions?
Hi, thank you for the talk. I have a question. In executors, what triggers the start of execution? When you do sync wait, or is something before that will trigger like the schedule chain already executing?
This depends on your executor. But at least when you say sync wait, when you wait for the result. But this could also be a lazy job, which would never start if you don't want to have the result. So I cannot say it in general. But this is essentially the power of this framework. You can adapt it as you like it.
Other questions?
Thank you for your talk. I have one question on the contractors, on the contracts. Basically, these the preconditions and post conditions. Will there be an option to disable them? Say, you have them at the debug build or your private build, and then in production, you don't want to incur any.
Honestly, I cannot say it. They should be part of the first for C++ 20. They talked about it, and there with 20, it should be possible.
Okay, thank you.
But I found so far nothing in 26. And you know what? Why they were removed from 20? There were some issues. Maybe this one. But I assume you can adapt them to your needs.
So I have a question actually. Of all of the things that you talked about, thank you for that, by the way. Which of those things are already merged into the working draft, and which things are still possible?
They should be. There should be almost in the working draft, because what I did was the following. I visited cpreference.com. And also Herb gave a statement that they are pretty cooked, let me say it this way.
I think they're still discussing contracts this week, so that may not make it yet. I know that much.
But this would be very terrible. The last time they were kicked out was, I think, in Cologne in Germany.
Yeah. Yeah, let's hope. Let's hope.
Yeah, but there are still other features which we may get, such as pattern matching. But I never mentioned them here.
Yeah. Any other questions? Okay, well, thank you very much, Rainer, for an excellent talk on C++ 26.
Yeah, thanks a lot.